So I want to take a look at some of the things in the first tutorial in the Foundations of Inference section. And there are a few things in there that you might find unfamiliar, not very clear. So let me walk through this. First of all, of course, we have to do the usual library thing to get all the packages we need. And one question you might have is, what was originally in this SOTA data frame? And the SOTA data frame was actually created with this little snippet of code here. And it creates a vector called drink, which repeats cola 47 times, then repeats orange 10 times, 13 times. And then the location had 28 east, followed by 19 west, followed by 6 east, followed by 7 west. Okay? So you've got 60 things in both drink and location. There are 60 long vectors. And this is the core piece of code that we need to understand. And what I'm going to do, instead of doing all this piping, I'm going to leave some pipes there, but I'm going to walk through this thing step by step and show you what happened. Okay? So the first thing to do is create what I call step 1. And it takes SOTA, and then it mutates. Drink underscore perm is sample of drink. And we'll talk in a few minutes about what sample of drink does. And then we look at step 1, and it's a data frame, and it has a new column, drink underscore perm, which is really just a reshuffling of this column. The first row was East Cola, and now it's East Orange. And the second row was East Cola, and it is still East Cola, and so on. So here's all 60 rows of the data frame. Okay? And then I did a table to compare the before shuffling and after shuffling versions of drink. And before you had 47 colas, now you have 37 colas and 10 oranges. And before you had 13 oranges, now you have 10 colas and 3 oranges. Notice that the before and after are the same. That is, 37 over 10 is 47. 37 over 10 is 47. 10 over 3, and 10 plus 3, and 10 plus 3. They're the same. Okay? So that is what Shuffle did. Now, what does Shuffle do in general? And I just thought I should take a very simple example. Take a vector of just simple integers, 1, 2, 3, 4, 5, and take a sample of it. And what you get is 5, 1, 3, 4, 2. Do that again, and you get 1, 5, 3, 2, 4. Do that again, and just by coincidence, you get 1, 2, 3, 4, 5. So what it is doing is just simply randomly rearranging the things in this vector. Okay? Step 2. So I take the data frame that you got out of step 1, and instead of piping, I just saved it as step 1, and then I group by location and summarize these two things. Prop underscore cola underscore perm is the mean value of drink underscore perm is equal to cola. And that is the fraction of drink underscore perm, which is cola. And then the prop underscore cola is the mean of drink equal cola. So this is the original. So you're comparing the original proportions with the proportion after. Okay, and this is done for each location. So for the east, originally you had 82.4% colas, but now after you reshuffle it, you get 76.5% colas. And for the west, Before, you had 73.1% colas, and with shuffling, you get 80.8% colas. Okay. Step 3, take the results of step 2, and then you calculate diff underscore perm is diff prop underscore cola underscore perm, and diff underscore original is diff prop underscore cola. So this is the difference between west and east for the permuted or shuffled versions of drink, and this is the difference between west and east for the shuffled version. And you might want to know, what does diff do? Well, again, I created a simple vector. This is not just 1 through 5, it's 1, 2, 3, 5, and 8. And then I said, let's look at the diff of x. So notice that here what I've got is a 5 long vector. Here the diff of x is a vector which is of length 4. And where does this 1 come from? Well, it is the difference between 2 and 1. Where does this 1 come from? It is the difference between 3 and 2. Where does the 2 come from? It's the difference between 5 and 3. And where does the 3 come from? It is the difference between 8 and 5. So I hope with this little bit of assistance in dissecting that code, it'll be clearer to you. Okay?